So suppose this is a lens, this is a convex lens, this is a convex lens, and this is the principal axis, and here is a point, optical center, and this lens is thin lens. This lens is thin lens. Thin lens. Thin means the thickness of this lens is very, very small. In our syllabus, I told you there are thin lenses. And around this lens, okay, so first suppose the refractive index of the lens is NL. NL is the refractive index of lens, and this lens is placed or you can say this lens is surrounded by some medium. This lens is surrounded by some medium, and that medium can be air, sometimes that medium can be water, that medium can be any other medium like oil. So I'm supposing N suffix M is the refractive index of surrounding medium. Refractive index of surrounding medium. Refractive index of surrounding medium. So the refractive index of surrounding medium is Nm, and refractive index of the lens is Nl. Okay, so here an object is placed. This is the object. Here the object is placed, and I told you the lens is the combination of two surfaces. So one surface here is this, and another surface is this. So two surfaces are there, and both the surfaces are convex surfaces. So first surface is this, and another surface is this. So for this surface, this one surface, I'm supposing this is the first surface. This is the first surface, okay. So for this first surface, the center of curvature will be this side. Suppose this is C1. C1 is the center of curvature for the first surface. So if C1 is the center of curvature, then R1 is the radius of curvature for this first surface. Our radius of curvature means this distance. This distance will be the radius of curvature R1. And for this surface, the radius of curvature is R2. So for this surface, the radius of center of curvature will be this side, C2. I told you in the last classes. Okay. So this is the object, and suppose a ray of light from the object is going like this, from here to here, like this, striking on this surface, and okay, and is striking on the first surface. This is the first surface, okay. The ray of light from the object is striking on the first surface, and this surface is a spherical surface, and suppose the lens, the medium of the lens is denser as compared to the surrounding medium. So you can say, suppose the light ray is going from rarer medium to the denser medium. So we will draw the normal, and normal passes from the center of curvature. I told you normal passes from center of curvature. Normal passes from center of curvature. This is the normal for the first surface. Suppose this is N1, normal for the first surface. Now the light is going from rarer medium to the denser medium. So it will bend towards the normal. It will bend towards the normal. So the image will form like this. You can see here. Bend towards the normal. Bend towards the normal, image will be somewhere here. But there is one another surface here. There is one another surface here. Okay. So if this surface is not present, then the image will form somewhere here. Okay, like this. But there is another surface there. Suppose this image is I dash. Now we will see this surface. Light is going from a bending towards the normal. Now the light is striking. Now the light is strike. This is the image formed when there will be no this surface. When there will be absence of this surface. Okay, but this surface is available, so we will draw the image with respect to this surface. So now light is bending like this from here. Now here what will happen? This is the second surface. Now light is striking to the second surface, and now again you will draw the normal for the second surface. For the second surface, the normal will pass from the center of curvature like this. So normal will always pass from the center of curvature of the surface. So this is suppose N2. N2 means another normal. Now for this light, uh, this is the normal and this is the light. So light will bend away from the normal, as this is the denser medium and light is going to the rarer medium. So light will go like this, something like this. So finally the image will form at this point here. This is the final image, means this is the final image. Okay, so this is the image when there is the absence of this surface, and this is the final image when both the surfaces are there. Okay, so this distance, talking about this distance, this is the NL. The distance between optical center and the image is the image distance. This distance is V. This distance is V. Okay, and suppose this distance is this distance is V dash. This distance is V dash. We will apply the and we will apply the length. Sorry, this formula. We have the formula for the refraction from the spherical surfaces. So we have this formula I told you, n2y_v minus n1/u is equal to n2 minus n1/r. So here n2 is the refractive index of the medium in which the light is going, and n1 is the refractive index of the medium from which the light is coming, and v is the image distance, u is the object distance. So in this case, first we will apply this formula on this first surface, first refraction from first surface. So for the first surface, first surface. So for the first surface, apply this formula, means put the values. What will be the value of n2? N2 will be the refractive index of the medium from which the light is coming. So n2 will be nm and n1 into nl. nl means the refractive index of the lens, n suffix l. Okay, this is n suffix l. Object distance is this. Okay, object distance is this. This is the object distance, u. Okay, so put the values here in this formula, n2/v, n1/u. So for this object means for the refraction from this first surface, this will be the object distance, and for this surface, the image will form here. So image distance you will take this. So you will write n2/v minus v dash, n2/v dash, okay, n1/u. Instead of n2 we will put nm. So nm by u v dash minus nl by u is equal to nm minus nl divided by r1. So r1 will be the radius of curvature for the first surface. So this is the first formula we have. Now we will apply for the second surface. This formula for the second surface. For the second surface means the refraction from this surface. So light is going like this. So light is going from denser medium to the rarer medium. So this time n2 will become nm. This time n2 will become not nm. n2 will become nl. Just wait. So this now for the second surface. Second surface means light is going to the this medium having the refractive index nm. So this time n1 is equal to nm. This time n1 becomes nm and n2 becomes nl. What is nm? Refractive index of the surrounding medium. What is nl? Refractive index of the lens. Okay. Now again we will apply this formula n2 by v minus n1 by u is equal to n2 minus n1 by r. So n2 is nl. What will be v? V will be v this time, because for this surface the image is forming here, so you will take this v. Okay, n2 by v minus n1 by u. N1 means nm. What will be u here? What will be u here? So u here will be this v dash, because this I dash, that is why I have drawn I dash here. So this I dash will be the virtual object for this surface. This I dash will be the virtual object for this surface. So you can write here, this is v dash, and this is equal to n2 minus n1 means nl minus nm divided by r2, because you are applying the formula for the second surface, and second surface have the radius of curvature of r2. Okay. So write this point here, I dash acts as virtual object for second surface, for second surface. So for this surface, this I dash will work as virtual object. Okay, so changing here, nl by v, nl by v is v, and nm by u is v dash, and n2 minus nm by nl minus nm divided by r2. So this is equation number 1. Suppose this is equation number 2. Now add both the equation. Add equation number 1 and 2. So when you will add both the equations, see, when you will add left hand, you will add this left hand side of both the equation and right hand side of both the equation. So this nm by v dash and nm by v dash will be cancelled out. So finally you will have nl by v minus nl by u. We will have nl by v minus nm by u is equal to, you have nm minus nl by r1, nm minus nl by r1 plus nl minus nm by r2, nl minus nm by r2. Okay, so this is nl by v. We will further solve it, and m by u. Now you can take nm minus nl common. How you can take common? If you will take here minus common, so it will become nm minus nl. So it will become nm minus nl when you are taking common. So it will become 1 upon r1, and here it will be minus sign and 1 upon r2. Actually here will be this nm here will be nl, not nm, nl. Here also be nl. So take out nl common. from here. So 1 upon v minus 1 upon u, and here what is common? NL you have taken common. Now there is one formula uh, for the mirror, for the lens. For the lens there is a formula. 1 upon f is equal to 1 upon v minus 1 upon u. Means this formula is valid for the lens. 1 upon f is equal to 1 upon v minus 1 upon. Okay. So this is the formula for calculating the focal length for the lens, or for calculating the position of the image or position of the object accordingly, which quantity is given and which quantity is asked. Okay. So 1 upon v minus 1 upon u can be written as 1 upon f. Okay. So it can be written as NL into 1 upon f is equal to NM minus NL 1 upon R1 minus 1 upon R2. Now it will be 1 by f is equal to Nm minus Nl divided by, this term will be in the denominator like this, Nl, and you will have 1 upon R1 minus 1 upon R2. Okay. Now 1 upon f is equal to, you can write this term, you can divide this NL to Nm and NL. So it will become Nm by NL minus 1, and it will be 1 by R1 minus 1 by R2. So this will be the lens maker formula. This will be the lens maker formula. So f is the focal length of the lens. F is the focal length of lens. Nm, already written, what is Nm? Refractive index of surrounding medium. NL is the refractive index of the lens. Okay. R1 is the radius of curvature. R1 is the radius of curvature for the first surface. And what is the first surface? Means how we will decide the first surface? Means the surface on which the light will incident first will be the first surface. R1 is the radius of curvature of the first surface. R2 is the radius of curvature of the second surface. Okay. Okay. Now you can take the screenshots. This is the derivation of lens maker formula. Once again, I am telling how we have derived. Okay. Once again, I am telling, just wait. Okay. So this was the lens we have, and this is the surrounding medium. Lens have the refractive index of n suffix l, and the surrounding medium have the refractive index of n suffix m. So I have supposed here an object is placed, and from this object uh, the ray is going like this, and after refraction image is formed here due to this surface. Due to this surface the image is formed here, and due to this surface the image is formed here. So you can say, for this surface, this is the object, and this will be the image, this, and for this surface this will be the virtual object, and this will be the image, and you will put in this formula. This is the formula earlier derived by us. Okay. And after putting all the values of Nm and Nl, you will get two equations, and when you will add those two equations you will get this, and accordingly you will get this. Okay. You will take NL common from here, and this formula you will use. This is the formula for the lens formula. 1 upon f is equal to 1 upon v minus 1 upon u. So 1 upon b minus 1 upon u can be written as 1 upon f, and accordingly you can solve and you will get this formula. Now you can take the screenshots. Done, Matthew, Nafisa, Nawal?
Yes, sir.
Yes, sir.
Okay. In this formula, R1 and R2 and focal length, we will put with sign. With sign we will put. So on this formula, now we will solve some of the questions. They are saying find focal length number one, biconvex lens R1 is equal to R2 is equal to 10 centimeter, and the refractive index of lens is 3 by 2. Length is kept in air. So there is a bifocal biconvex lens. This type of lens is there. This type of lens is there, and this is known as the biconvex lens because there are two convex surfaces. That is why this is known as biconvex lens. So first radius is this of this surface. This is the suppose the center 1. So this will be R1. Suppose this is a center 2. So this will be R2. Okay. Suppose and the light is coming in this direction like this. This is the incident light. This is the incident ray. So if this is the incident ray, this direction will be considered as a positive direction. And this direction you will consider as a negative direction. Okay. So this is only given that object is placed here, so incident ray will be like this. So we want to find the focal length. This direction is the positive direction and this direction is the negative direction. So we have to find the focal length of this lens. To find the focal length of the lens, we have a lens maker formula. What is that? 1 upon focal length is equal to refractive index of the lens divided by refractive index of the surrounding medium minus 1 multiplied by 1 upon radius of curvature of surface 1 minus radius of curvature of surface 2. Refractive index of the lens is 3 by 2. So here in this question, refractive index of the lens is given as 3 by 2 means 1 by 1.5. And refractive index of the surrounding will be air. Refractive index of the surrounding will be 1. Why? Because surrounding is air only. So the refractive index of air is 1. And R1 and R2 is given as 10 centimeter. Now R1, when you will measure R1, suppose this is the optical center. When you will measure R1, remember one thing, this lens is very thin lens. So this distance will be measured from here. This R1 can be measured from here also. So you will measure the distance in this direction. And this means you will measure the distance from optical center to the center. What is R1? R1 is the radius of curvature. The distance between the optical center and center of curvature. I am marking like this. Otherwise, you will get confused. This is C2. This is your R1. This is your R2. Now, for R1, you are measuring the distance in the direction of the incident light. So R1 will be positive. So you will take R1 is equal to both R1 and R2 are of 10 centimeter, but R1 you will take plus 10 centimeter. Why? Because you are measuring R1 in the direction of incident light. For R2 is this. So you will measure R2 in the opposite direction of the incident light. So this direction is the opposite direction of the incident light. So this will be considered as negative. So R2 will be minus 10 centimeter. R2 will be minus 10 centimeter. Now put all the values in this formula. You will get the answer very easily. 1 upon F is equal to NL is 1.5, NS is 1 minus 1 upon R1 means 1 upon plus 10 minus 1 upon R2. 1 upon R2 is minus 10. Okay. 1 upon F is equal to, so you can take LCM. 1 will be the LCM. So you will get 1.5 minus 1 means 0.5 divided by 1 multiplied by, here you will get 1 by 10 plus 1 by 10, because here is minus plus. So you will get 1 upon F is equal to 1.5 is 1 by 2 multiplied by, you will get 2 by 10. 2 by 10. 2 and 2 will be cancelled out. So 1 upon F is equal to 1 upon 10. So F you will get plus 10 centimeter. F you will get plus 10 centimeter. So this is the focal length. This is the focal length of this lens. So you have calculated the focal length of this lens with the help of the lens maker formula. So this is the derivation of the lens focal maker formula. How you will derive the lens maker formula. You have derived the lens maker formula by using the refraction, by using the concept of formula of refraction from the spherical surface, and finally you got this formula. And for calculating the focal length of the lens with the given data, you will use this formula. Please take the screenshot. There is one more question on it. We will solve. Scroll down, Matthew.
Yes, sir.
Okay. So next question. So this type of lens, this time we have plano-convex lens. Plano, this is a plane surface and this is a convex surface, plano-convex lens. So it is given that for this surface, the radius of curvature is 20 centimeter is given. And this lens is placed in air around it. And refractive index of the lens is equal to 1.5, and focal length is equal to 40 centimeter plus 40 centimeter, because the the focal length of this lens is plus 40 centimeter given. Oh, actually this we have to calculate. uh, you have to calculate the focal length of the lens. You have to calculate the focal length of the lens. Okay, refractive index of the lens is given. So again, for calculating the focal length of the lens, what we have the lens maker formula. We will apply the lens maker formula. 1 upon f is equal to 1 upon f is equal to refractive index of the lens divided by refractive index of the surrounding medium minus 1 multiplied by 1 upon refractive radius of curvature of surface 1 minus radius of curvature of surface 2. Now you can see here, this is the surface 1, R1. This is the surface 1, R1. So just draw the principal axis and draw the direction of the incident light. This is the principal axis and the light is coming in this direction like this. This is the incident ray. Incident ray. So means this direction will be positive direction. So for this lens, for this surface, center of curvature will be here. Center of curvature will be here. So this will be the radius of curvature R1. So you will measure the distance in this direction, and this direction will be considered as positive direction. So R1 will be positive. So we will take R1 is equal to plus 10 centimeter. Now, can anyone tell me what will be the value of R2? R2 means the radius of curvature for the plane surface. For the plane surface, what is the radius of curvature, Matthew?
0 degree.
Hmm? What?
Can you repeat a question, sir?
Uh, I am saying what is the radius of curvature for this plane surface?
R1.
No, no, no. Actually, for the plane surface, the radius of curvature will be infinite. Always remember, for a plane surface, the radius of curvature is infinite. So R2 will be infinite here.
So how will you calculate it then, sir?
Actually, this we cannot calculate because we consider that if there is a sphere, if you are taking this surface only, okay. If I am removing this, I have just removed this plane surface, and I have a spherical surface. So it is assumed that when this will become straight, this will become straight like this. So when this will become straight, the radius of curvature will increase and increase and increase. And when it will become finally straight, so the radius of become so large, it will become infinity. Okay. So
Okay,
this
sir.
point you have to remember. You have to remember this point. So R2 is infinite. Now put all the values in this formula and tell me the answer. NL is this. And NS, what you will take NS? NS means the refractive index of the surrounding medium. You will take 1. NS is equal to 1. NL is equal to 1.5. Just do this question. I am giving you 3 minutes. And one more thing I want to tell you if you don't know. 1 upon infinity is equal to 0. Okay, please try this question by yourself. Means I have done the question already. You have to just put the value and find the focal length only. You have to find this focal length by putting all these values. Just try it.
Sir,
Hmm.
So it's 0.60.
0.033. Oh,
Okay. Okay, I'm solving. Check your answer. It will be 1 by f is equal to NL is this 1.5 and NS is 1 and this is minus 1. 1 upon R1 is 1 upon 10. 1 upon R2 is 1 upon infinity. So 1 upon f is equal to, from here you can write, take LCM 1, so it will become 1.5 by 1, 1.5 minus 1
0.
divided by 1. So it will be 0.5 by 1. You can write only 0.5 by 1 or 0.5, or you can write 1 by 2 multiplied by 1 by 10. This is 1 by 10. Okay. So you will get 1 upon 20. So focal length na you will get plus 20 centimeter. This will be the answer. Okay. So you have to put the values in this formula and you will get the answer. Okay, take the screenshot.
Done.
Done. Okay. So after this, we will discuss magnification in lenses. Magnification in lenses. Magnification. So magnification in lenses magnification in lenses. So we will discuss here the linear magnification. And this linear magnification is also known as lateral magnification. And this lateral magnification is also known as transverse magnification. There are three names of the linear magnification here: linear magnification, lateral magnification, or transverse magnification. Because we are talking about the length of the object and the image. Transverse magnification. Okay. So the formula for the magnification is height of image divided by height of object divided by height of object. You can write this as height of image divided by height of object, and this is equal to V divided by U. This is for lens. But earlier I told you, in case of mirrors, there is a similar formula, but here is the negative sign for the mirrors. You can check in case of the mirrors, we have the magnification. Magnification, na? Mirror. Actually, the notes were not available, I think. See, in case of the mirrors, magnification is given by height of the image divided by height of the object. That is equal to minus v by u. So see the difference between the lens and the mirrors magnification. So this formula will remain same, height of image by height of object, height of image by height of object. But in case of lenses, you have v by u, and in case of lenses, you have minus v by u. Okay, so number one. If the magnification is positive, if the magnification is positive, so magnification is positive means you have magnification is equal to height of image divided by height of object. So magnification is positive means the sign of height means hi and ho will be same sign, either both positive, either both negative. So hi and ho have same sign. What is the meaning of hi and ho same sign? For example, suppose this is the principal axis, and I am saying the object is like this. An object is placed like this. So if object is like this means height of object is positive. This is the object. Height of object is positive. And in the same way, if magnification is positive, then we are saying the image will be like this. This is the image, and this image will be also have the positive sign because this is the principal axis, and above principal axis all the distances measured are positive. So here now you can see this is the object and this is the image. So the image is erect image. We are getting erect image, and erect image is also virtual image. Erect image is also virtual image. So what can you say when the magnification is positive? When the magnification is positive, then we can say the image will form virtual and erect image. Finally, you can say virtual and erect image. Virtual and erect image. Okay. Virtual and erect image. Secondly, if the magnification is negative, we have taken first case when the magnification is positive, what will be the nature of the image? So when the magnification is negative, magnification negative means magnification is height of image divided by height of object. If the magnification is coming out to be negative means height of image and height of object have opposite sign. Hi and ho have opposite sign. What is the meaning or what is the significance of opposite sign of object and image? Height. This is the principal axis. If the object is placed, suppose like this, if the object is placed like this, if the principal axis, this is the object. So the height of the object you will take positive. So we are saying if the magnification is negative, then uh, both the signs of HI and HO will be opposite sign. So we have chosen already positive sign for height of object. So we have to choose negative sign for height of image. So height of image here you can draw like this. So height of image is negative. Then now you can say both have the opposite sign. So now this is the image. This image is inverted image. This image is inverted image. And inverted image is also real or real. Inverted image is also real. So finally what you will get, when the magnification is negative, when the magnification is negative means the image is real and inverted. Image is real and inverted. Understanding, Nawal, Nafisa and Matthew? The
Yes.
concept of the
Yes,
magnification?
sir.
Okay. Okay, take the screenshot. Just wait, just wait. Okay, now, just a minute. Now take the screenshot. Okay. So we'll see one question on the magnification and the lens formula. Find position, size, and nature of image. Formed by convex lens, formed by convex lens of focal length 10 centimeter when a 2 centimeter long object is kept in front of lens in front of lens at a distance of 15 centimeter, distance of 15 centimeter. So there is a convex lens, hmm, this type of lens. A lens is there, and an object is placed at a distance of 15 centimeter from this lens. So we have to draw the principal axis. This is the principal axis, and the object is placed here and at a distance of 15 centimeter. 15 centimeter from this is the object. So object distance u is 15, and the light from the object will be like in this direction. So this direction will be considered as positive direction, and object distance will be negative because this is the optical center, and you will measure the distance from you can represent optical center this time with C. O is the object. So optical center, you will measure the distance in this direction from C to O, but the direction C to O is negative, so you will take U as negative. U as negative. So U is equal to minus 15 centimeter. Okay. And this here the object placed na having 2 centimeter height. The height of the object is 2 centimeter long. So if this object is above principal axis, so this height will be taken as positive. So height of the object you will take plus 2 centimeter. Anything else? Focal length is given. Focal length of the lens is 10 centimeters. So this is a convex lens. For convex lens, the focal length is positive. For concave lens, the focal length is negative. So you can write here. For convex lens, focal length is positive. For concave lens, focal length is negative. So focal length is given as 10 centimeters. We will take it as positive because for convex lens, the focal length we take positive. Okay. So if you are going in this direction, so this direction will be considered as negative direction, and this direction is the positive direction. Okay. Because light is going in this direction, so this direction will be considered as positive direction. You have to find the position, size, and nature of the image. So we will apply the lens formula, that is 1 upon f is equal to 1 upon v minus 1 upon u. So position of the image means this image distance you want to find. Image distance you want to find. So you have focal length, you have object distance, you can calculate the image distance. So from here 1 upon focal length is plus 10 centimeter is equal to 1 upon V you have to find minus 1 upon U. U is minus 15 centimeter. This is minus 15. So from here you can find this 1 by V. So 1 by V is equal to 1 by 10, this minus minus plus, and it will become minus 1 by 15. You can take LCM 30. So it will become 10 3 the 30 and 5 2 the 30. So it will become 1 by 30. So the position of the image V you will get plus 30 centimeter. Plus 30 centimeter means the image is formed this side here at a distance of 30 centimeter. So it is confirmed that the image is formed in the opposite side of the object. So this is the image, means 30 centimeter. But right now we cannot say whether the image is inverted or whether the image is real, inverted or erect. So that we can say with the help of another formula. Magnification formula we have height of image divided by height of object is equal to V by U. So right now what we have? We have U, but we do not have height of the image. Okay. So first we will find the magnification from V by U. So what is V? V is plus 30 centimeter, means plus 30, and U is minus 15. So it will be minus 2 centimeter. So magnification is coming minus 2 centimeter. I told you that if the magnification is negative, then you will say the image is real and inverted. So image is real and inverted. So magnification is negative, so you can say image is real and inverted. If magnification is comes out to be positive, then we will say the image will be virtual and erect. Now we want to find the height of the image. Means they are asking position. So position we have already calculated. This is the position. Size means the height of the image. So height of the image we can find with this formula. Height of image, height of object is equal to the magnification. So magnification is equal to height of image divided by height of object. So this is equal to magnification is minus 2. So height of image is this, or height of object is given as plus 2. This is equal to minus 2. This is equal to height of image is equal to 2 to the 4. It will become minus 4 centimeter. So height of image is minus 4, and minus sign is indicating here the image is formed below the principal axis. So at this point the image will form below the principal axis, and the the height of the image will be of 4 centimeter. 4 centimeter. This will be the image, and this image will be inverted image. This will be the inverted image. Okay, Matthew.
Yes, sir.
Okay. So now you can just identify whether the image is inverted or not. From the this from this height of image is comes out to be minus 4 centimeter. Na? So minus 4 means you will say this negative sign is indicating here. This negative sign is indicating here the image is inverted. So why I am saying here the image is inverted? Because this negative sign means this height is measured below the principal axis. Below the principal axis means like this. Okay, please take the screenshot.
Done.
Done. Okay.
Done, sir.
Okay. So tomorrow, not tomorrow means in the next class, we'll finish this chapter.
Okay.
Hmm. So okay, try one question. I'm giving one question from my side. The question is, this type of lens is given. Plano concave lens. So this surface has the radius. Okay, this surface has a radius of curvature as 10 centimeter. Okay, radius of 10 centimeter, and the refractive index of the lens is 1.5. You have to find the focal length of this lens. Just try it, all of you. You have what you have to do. I am giving you the hint. You have to apply this formula. 1 upon f is equal to refractive index of the lens divided by refractive index of surrounding minus 1 multiplied by 1 upon r1 minus 1 upon r2. Lens maker formula.
Sir, is that just R or is it R1 or R2?
This lens is plano concave lens. So for this surface, radius is for this surface. What will be the radius of curvature? Infinite,
Infinite.
because this is a plane surface. So you can take this surface as a first surface and this surface as a second surface. Okay. So your R1 will be infinite and your R2 will be 10 centimeter. And refractive index of the lens is 1.5 centimeter, but it is not given here that what is the surrounding medium. If nothing is given, then you will consider the surrounding medium as air. So refractive index of the surrounding medium will become 1 because air is there and refractive index of air is 1. Then you will apply this formula, 1 upon f is equal to this. So you will calculate it, 1 upon f you want to find is equal to NL, that is 1.5 by 1 minus 1, 1 upon R1 means 1 by infinity minus 1 by 10, 1 upon F is equal to, it will be 0.5 multiplied by 1.1, 1 by infinity is 0. 0 minus 10 will be minus 1 by 10. So it will become 1 by F. 0.5 can be written as 1 by 2 and it will be minus 1 by 10, and when you will multiply this you will get 1 upon minus 20. So the focal length of this lens becomes minus 20 centimeter. Minus 20 centimeter. Now the focal length is coming as a negative. You can just see here, this of this lens, the focal length is coming out to be negative because this is a concave lens. The overall behavior of this lens is concave. That is why the focal length is coming out to be negative, because the focal length of a concave lens is negative. For a convex lens, the focal length is positive. So in this way, you have to solve the question. There are two things in physics. Basically, I will say there are three things in physics. First is the theory. First is theory means uh, like what are the laws of reflection, what is refraction, what is interference, what is diffraction, what is electromagnetic induction, what are Faraday's law, what is Biot-Savart law, what is Ampere circuital law, what is electromagnetic spectrum, uh, what is electric field, what is magnetic field, what is electric potential, what is electric flux. This is what is and what and why. It means basically I will say this is the theoretical part mostly. Okay, this is the theoretical part mostly. Another thing in physics is the derivation. For example, derivation of electric field at a point on the axis of a ring. Okay, so this is the derivation here. Okay, we have to drive the electric field uh, at a point of a ring on the axis of the ring. Another derivation, you can say, drive the lens maker formula. Okay, drive the mirror formula. So there are the derivations. Drive the uh, means uh, displacement current expression for drive the expression for the displacement current. So when you are driving something, when you are driving some formula, and when you are driving for some physical quantity in physics, so there will be certainly we take some assumptions. Okay, and for derivation, you have seen, you have also have the experience of 10 months. Means from 10 months you are studying, I think, 12th physics. Uh, So you have analyzed in this that for driving something, first you are assuming and you are applying the maths. You are applying maths. What is the meaning of math? You are applying geometry. You are applying differentiation. You are applying integration. You are applying some other concepts of math. Okay. So you are applying maths to drive the formulas and all that. And the third part is the numerical. So numerical part is completely analytical part. Analytical means to break down the problem in different parts and then focus on that different part. Okay, is the numerical. So for solving the numerical, first the most important thing, you should know properly the derivation. Okay, you should know properly the derivation, or I will say that if you are not able to get the derivation properly of some formula, then at least you should know what are the values in that formula. I mean, what are, suppose if in this formula I am asking what is R1, then you should know whole concept of R1 and R2. What is R1 and what is R2? What is NL? What is NS? What is focal length? So these things should be clear. Then only you can put the value, and then only you can get the answer.